Hello everyone, my name is Abraham Tan Kuan Shi from SMK Dato Ali Haji Ahmad, and today I will teach you how to make a wrestler board. So this is what the wrestler board looks like. It has two motors, which are our wheels. We have a 9-volt battery which provides power to the L293D driver, an Arduino, a micro servo that sweeps away obstacles and objects, and an ultrasonic distance sensor, which is something that senses objects. Now that you know what we are making, let me teach you how to make it. So first, we grab an Arduino. Next, we grab a small breadboard like this, and we drag the power from the 5 volt on the Arduino to the positive line here on the small breadboard. We can change the colors via this drop down. So 5 volt to the positive, ground to the negative. Okay. Now that's done. Let's link this side to the other side. That's one, and that's another. There we go. Okay, now that we have the wires and small breadboard done, let's grab our L293D driver. This is a motor driver. It can control the speed and direction of motors. So let's wire it up. First, enable 1 and 2 on the left goes to positive on the small breadboard. Power 1 also goes to the positive on the small breadboard. Enable 3 and 4 also goes to the positive on the small breadboard. That's pretty much all of the positives done. Now let's do ground. Ground, we have these 4 middle pins. 1, 2, 3, and 4. So 1, 2, 3, and 4. Like that. Now that is done, let's grab a 9-volt battery. This component, this battery actually, provides power to the L293D, which provides power to our motor. So negative goes to negative like this, and positive goes to power 2. That's it. Now let's grab our motor. We'll be using a gear motor today. Gear motor, like right here. So the reason why we are using a gear motor is because the gear motor spins slower than the DC motor and is more suitable for the speed. So output 4 goes to negative and output 3 goes to positive. Like that. Let's do this on both sides. So another like this goes to output 2, and this negative goes to output 1, like this. Okay, let's link up the L293D driver to our Arduino. To do that, we grab the input 4. Let's drag this to pin 9. Now let's grab our input 3 and drag this to pin 6. Like so. Okay. Oh. Okay. Now let's grab input 1 and drag this to pin let's drag this to pin number 5 like this, and input 1 goes to pin 3. And input 2 goes to pin 5. Like that. Okay, now that our motor and L293D driver and breadboard are all set up, let's grab a ultrasonic distance sensor. This is a sensor which senses objects and tells the robot what to do and when to do it. So negative, which is ground, goes to negative right here, and our power, which is positive, goes to positive right here. You can drag these 5V and ground wires to whichever side you want, but I think this looks nicer. So signal, we'll be using yellow, and we'll drag this to input pin on the Arduino number 2. Okay, there we go. Okay, now that's done. Let's drag a servo, a micro servo right here. Let's rotate this. This will be what will be sweeping our objects and obstacles to the side. So ground goes to ground. Let's change the color. Okay, and power goes to red, positive, like this. Change the color, and our signal will be going from the servo to pin 12. Okay, now our wiring is complete. These are all of the components, and let's get on to programming. So first, we should create a variable called sensor, like this. Next, drag a set sensor to read ultrasonic distance sensor on trigger pin number 2, because our ultrasonic distance sensor is on pin 2. What this variable block does is that it tells the Arduino what the ultrasonic distance sensor is connected to. Next, we drag a if then block. Next, drag a comparative block, and sensor, we drag this variable to here. So what we want to do first is what the robot will do when it does not sense anything within 10 centimeters. So let's do more than 10. It will set. Okay, next drag 4 of these set pin to number blocks from the output tab, and we want to assign them to the pins that we assign the motors. So 3, 5, 6, and 9. Next, we can control the speed that we want the motor to turn at. So I want it to spin at 100 RPM. So like this. Let's try this out. If sensor is more than 10 centimeters, then it will go forward. Okay, the sensor is more than 10 centimeters, and these two motors are turning in the right direction and at the same speed. So we got that right. Next, we want to do what it will do if it senses something within 10 centimeters. So what we want to do is, if it senses something within 10 centimeters, we want a robot to slow down, and when it senses something within 5 centimeters, it will stop and sweep away the object. So what we want to do first is drag this end block from the math tab and drag 2 of these comparative blocks and drag them into these slots, these empty slots. Drag the sensor variable like we did just now, put them here. Okay, so we want it to be in between 10, so more than 5 and less than or equal to 10, like that. If it senses something within 10 centimeters, we want it to drag these blocks again. Wait, we can just duplicate this from here. We want it to go at 10 RPM, which is a significantly slower speed. The reason why we want it to go much slower is so that it can responsively detect the object and sweep it away at the right time. So let's try this. Nothing. Okay, let's drag this to less than 10 and 10 RPM. There we go. That's right. Everything is working fine. Okay, now we want to tell it what to do if it senses something within 5 centimeters. Between 5 and 3 centimeters. I'll tell you why we do 5 and 3 later on. So again, like just now, and drag the sensor variable to both of these. So more than 3, less than or equal to 5. Then we want all our motors to stop. So let's assign all these pins again. Drag them out. 3, 5, 6 and 9. So we just leave it at 0 because we don't need it to be any other number, because we don't want it to turn, we want it to stop. Next, we want to rotate our servo to 180 degrees. So servo on pin 12 right here, as we can see, to pin 12 to 180 degrees, and wait for 2.5 seconds for the rotation to complete, and then we want to rotate back again so it can fully reset back to 0 degrees and wait 2.5 seconds. Okay, now let's try this out. So it senses something more than 10. Let's go to 10 centimeters. It slows down, and at less than 5, it will wait for a bit. Okay, well, something isn't set up correctly. That's because this is okay. Let's drag a weight here also. Let's try it again. There we go. It's turning, and it goes back and goes back again, like that. So there's a slight flaw with this, which I'm going to tell you the solution to later. So let's say it rotates halfway, right? And suddenly it's more than 10 centimeters, or sorry, more than 5. The servo will go, the servo will be at here. As you can see, the servo is weird now. It has a very weird behavior. So to solve that, we want it to reset on every single step. So we want it to reset here, pin 12 to 0 degrees, and wait 1 second. Let's do this on all of our previous steps except the 5 centimeter one. So like this, to 0 degrees. Your code should look like this right now, and let me show you. It does not do the weird moves now. And let's drag it to 10. Within 10, it goes slower, and at 4 centimeters, it will rotate. Sweep it away. Now we go up. The RPM starts going up, and it keeps going forward. So now our robot can only go in a straight line and push objects out. But what if the robot sees a wall? It will just keep going forward or keep sweeping it. But of course, the robot is not superhuman and cannot break the wall or sweep the wall away. So what we want it to do is, if it sees a wall, we want it, or an object that is unsweepable, we want it to go back and turn right. So what we have to do now is the exact same as this. So we can just duplicate this like that. So we want it to be more than, we don't need this. We can just drag a math block like that. Sensor less than 3 centimeters. We want it to go backwards. So to go backwards, we are not going to use these either. We are going to use these, because this circuit has a slight problem with the servo. One of the motors cannot go backwards while the servo is active. So let's set these pins up: 3, 5, 6, and 9. Okay, we want it to reverse, so this is low and this is low. Let's try it. Let's drag it all the way down, and it goes reverse. Yes, but a big problem with this is that, as you can see, it's 231 RPM, which is quite fast. We don't want our car to go zooming backwards very, very fast, because then we will knock into another wall backwards. So what we want to do is drag a wait block here. Let's wait let's wait 1 second, and it will still keep going because there is no subsequent action. So next we want it to turn. So to turn, we drag these pins, these blocks, 1, 2, 3, 4, assign them 3, 5, 6, 9, and let's change the speed. So in order to turn, we need this motor to go clockwise and this motor to go counterclockwise, so we can turn right. So we want this to be, this will be on pin, this is on pin 6 and 9. So 6 and 9 go forwards. So go forwards, we put this to 50 and put this to 50 like that. Let's drag a wait block so it can fully turn. Let's put 3 seconds so that it will do a 90-degree turn. Let's try it. Go backwards, okay, and this is positive, this is negative. Great, everything is working fine. Now let's test. So more than 10, it will go at 100, around 100 RPM. Let's go below 10. Oh, okay, below 10, it will slow down, 10 RPM, and when we drag it to within 5, these motors will stop and this servo will start turning, sweeping the object to the side. And if it encounters a wall which is within 3 centimeters, it will go backwards and turn right. Okay, great. Now your robot is done and this video is also finished. So thank you for watching this video, and like and subscribe. Thank you.